The broadcast is now starting. All attendees are in listen-only mode.
Good morning, everyone. My name is Phil Liu with XBOSoft, and welcome to our webinar this morning on performance testing considerations using JMeter and Google Analytics. It's great to have you here today. Today we're going to be talking about how we've been using JMeter and working with our clients on what Ed calls avoiding performance testing yourself into a corner. So if Ed could, here we go. Great. So first, a little bit about Exposoft. We are 10 years old now. We just celebrated our 10th anniversary, founded back in 2006, and we totally focus on software QA, either in consulting and helping our clients to improve their processes, or in actually doing the various types of software testing, from test automation as well as performance testing and regression and so forth. We're an international company with offices in San Francisco, Europe, as well as in China. And our motto is that we're thorough, accurate, and fast, which is pretty is a good tagline for today, because today is about performance testing. Just first, a few house rules. All of the participants, other than the speakers, are muted, but we will take a lot of questions through the question panel. So make sure that you put in questions that you have, and we'll also be doing a recording. So you will get the link to the recording right after the webinar. Yeah, the webinar is not really about me today. I'm the CEO and founder of Exposoft. I've been in the software quality field for a very long time. But today is really about our VP of Engineering, Ed Curran. Ed brings a wealth of experience in software development and software design, and previously had a life in the mobile world. So we're really happy to bring Ed on to lead our company in terms of our technical capabilities, and particularly he's been working a lot in performance testing as of the last 6 months or so, working with our clients in troubleshooting their performance as well as fine-tuning their performance of their software. So Ed, keep going. Great to have you here, Ed. Are you there?
I am here, and thanks for welcoming me.
Great. So, today's really all about you, and I guess that a lot of the participants are here either because they want to know some general things about performance testing, or maybe you've got some nagging headaches with JMeter. And I'm hoping that today the presentation that Ed's put together on some of his hands-on experience in JMeter will give you a good hand in solving some of your issues. So I'll just let Ed take it away from here. If you do type your questions into the question panel, I will see them and I'll moderate them and have Ed take a pause and hopefully be able to answer you. And of course, if we don't get to your questions and answers, we will post them on our blog with Ed's response, and so you'll be able to get them in that way. Ed, I'll let you go from here.
Okay, very good. Well, thanks, Phil, and thanks everybody for joining today. Just as an introduction, I am going to be talking about performance testing and load testing. One of the things that frames the discussion is the software testing challenges. And KPMG survey that was performed recently has some interesting facts about it, interesting facts about software testing, a lack of standard processes between different organizations and even within the same organization. 30% overruns, typical for development time when developing software. And there's more and more market pressures with regard to this whole software industry and development to get things out into the market. So there's a lot of challenges, and it really lends itself to a real need to be able to automate your testing to meet these needs. So a survey that was recently done in Europe shows the different types of automated testing that's taking place between or by different organizations, and it gives the percentages of the types of testing. And you can see that 82% UI testing, which would make sense because those are the customer-facing aspects. Performance is at 53% for all those that are doing automated testing or doing performance. And one other thing I wanted to just point out was the ecosystem at 6%. We'll get back to that. So automated testing benefits. 90% of the companies that have implemented automated testing have seen a return on investment within a year. I personally think that sounds pretty high and pretty good, but the number is very, very large for those that have seen benefit. And as the previous graph showed, there's a large range of different types of automated processes that are being employed. And as I stated before, there's that focus on the UI. Now there are practical challenges. Automated testing trends, practical challenges, you'll see that you need a good test environment. That includes configuration, maintenance, and it needs to be stable. And there are many types of automated processes, different types of tests that are available. So it's difficult to determine the types of tests. And the scripts, they need to be created and they need to be maintained. So those all require concerted efforts to do them and do them well. So you say, what's wrong with my performance testing? Well, some of the automation shortcomings for the testing, say 82% was focused on the UI. Only 53% was the performance testing for the types of automated testing that it was done. And as I pointed out, certain things can be left out, like ecosystems, which are becoming more and more important. The ecosystems are tied more and more to the software that's being developed, user applications, and could talk about mobile applications. And so the ecosystem is something that has been given or shown little emphasis with regard to performance testing, but it's just another critical piece of the system. So I put this performance test type down. We have these different types of performance tests, and they can come by different names, but the idea is how do you put pressure on the application to find out as the application is used by many users, how do you put pressure on that application? And so you'll have load tests, identifying bottlenecks, it could be arguably a generic term. Stress tests where you find breaking points, endurance tests for how long particular processes can continue while users are loading onto the system, spike tests as it sounds, volume testing, scalability testing. So all these are different ways and different shades of performance testing. But some additional considerations to take with regard to any of those tests are they don't stand in a vacuum. A particular process can be performed on a system, but many times that system is performing many processes, perhaps similar processes for users, maybe different processes for users. And as I stated before, with regard to the ecosystem and other parts of the system, software does not just exist within a vacuum. And performance testing, load testing, however you want to refer to it, is unusual. It has a time component, and that time component really, to be effective, needs to be exploited through automated testing. So there needs to be an automated way to keep driving the test over and over again over a period of time. So system complexity. Software is part of a system. As I've been referencing, the software does not exist by itself in its own little little bubble. It's part of a system. And it needs to be designed with those systemic requirements in mind. It's critical to consider it within the larger system. So what is it you really want to test? Well, something that I learned early on in my career was that what is quality? And quality is, it's not exceeding all of the requirements. You need to meet them though, and meet them reliably. So if you have a system that needs to support 1,000 users, simultaneous users, you don't need to design it for 15,000, but you should be able to design it for 1,000 and then have a buffer on top of that. And depending on what that function is and your rate of growth, it could be 1.4 times, it could be 2 times, or maybe you want to drive it to 4 times just to see if you have headroom. So you need to really keep that as an underlying theme as you're going through your tests of really what you want to be testing. So what we have is these high-level software test concepts. And these are just generic high-level concepts like smoke testing, happy path testing, which could be, it's just like simple functional tests. Negative and boundary tests, where you'd actually take those simple functional tests and actually push them to find out if, for instance, if you were entering in somebody's age and you entered in an age of 255, some unusual number that really shouldn't belong there, will the software deal with it elegantly, or does it crash, or something else happen? And then there's the aspect of timing and load, the timing dimension, as I call it, which is involved with performance and load. So these are the high-level concepts. So now I want to talk about what's a test. And this is a metaphor that I put down onto this document. And the first thing to look at is just H1. And H1, what that represents, it's a little box. It's just, this is your happy path test. So again, this is a metaphor, but it's a simple test where a happy smoke test, whatever you want to call it, that does a particular function. The next thing is this red box here, and this represents the boundary tests that could be taking place. So it's actually where you would take this with functional or happy path tests, and then you'd actually expand it by having negative or boundary tests. So now it's actually employing more, it's exercising the software more. And this could mean not just a happy path test, but maybe there'd be several tests now that would constitute this particular test. And then the last part is time. And you can see t equals 0 to t equals n, so it's just some finite period of time that you're going to drive this test. So it's not just that you do the test, it's that you actually do it many, many times, perhaps with many, many users or different parameters, and you could drive it over time. And the last thing I wanted to show on this is that you have this this particular TH1, which is basically just, it's time, but it's also segmented up. It does not have to be periodic, like once a second or something like that. It can be grouped into, dozens per second, or it could stop and then start again. And it would really depend on how you want to exercise the application to how that would be set. So I want to show this real world example. Now this is JMeter, for anybody that hasn't seen it. And in JMeter, I have this stepping thread group function. And what we're looking at is actually a design of that particular software test. And in this design, what we have is that you'll add 30 users, and I'll just go into part of this slope here. You can see the active users over here, and this is over time. And you'll have 30 users that are going to be added and then you ramp it up for 10 seconds, hold for 20, add another 30 users over 10 seconds, hold for 20, add another 30 users, hold for 20. And you'll keep going and ultimately descend down. So JMeter is very good with regard to being able to design this test because it's nice, it's visual, and in fact, if you go and execute the test, this is an actual test for a website that we were testing, and you can see that exact layout that I designed the test for. This is the actual loading that was being sent out to, this was the requests that were being delivered over to the server under test. And then the server responds. So if you look, you see the number of V users over on the right side now. You have the delay shown on the left. So basically, while we were doing this, while we're driving the application server, we're getting the responses, and the responses are in pink. And here you can see that here's 100 V users. So right around here, just above 100, the time becomes 5-second delay on the response. So we're below 5 seconds in the response, but as we pour more and more users on, we now are actually getting above 5 seconds delay. And the reason 5 seconds was interesting in this particular case was that the customer did not want more of a delay than 5 seconds when they were designing their application. They think that anything over 5 seconds would be intolerable for their users. So this was of interest to them to know that they could only support 100 simultaneous users. So getting back to my metaphor, my simple metaphor, it's a box metaphor, it's simple, it's well organized. But the real world is much more complex. So this is an extension of the metaphor where it shows that there's many processes that can be taking place. Now you can look at this as multiple tests, but even if no tests are taking place, it could be multiple processes that exist within a given application and that are taking place potentially simultaneously. And they could be well ordered. They're probably different sizes, which is really not shown well here. This is really this is overly simplistic how it's being displayed. But you do have that one block in the middle, this pink one, that's a skew. And that represents a particular process that might be bigger, involving more memory. It also, if you look at it, it's kind of running diagonal into some of the other processes. And it represents that it could be a process that's interfering with the other processes. Either there could be some sort of shared memory problem or memory leak. It could be a function that is a process that's gone rogue, it's gone bad and is not performing the way that it was expected. But the idea is that all these different processes are taking place within a given software application. And they could be all doing this simultaneously. So it's kind of what a test is at a high level. But then you need to also figure out, if you're going to start doing these tests and prioritizing what you want to do, you have to figure out where you stand. So one of the things that we think is, why drive load? Well, you want to determine the bottlenecks, where your application is going to run out of gas, or the application under test is going to run out of gas. So there's key factors and parameters that you could be varying to exercise the software. One of the things that you want to do, or that to aspire to, is to simulate the production environment. And as close as you can get to that in a real-world production environment, when I say an environment, I just don't mean the configuration of the computers and the application. I mean also the users that are using it. And then you want to run load tests and performance tests that would exceed the requirements. So then you'll find out where you're going to run out of gas and figure out the level of buffer that exists within your application. So how do we do this? Well, at Exposoft, we've used this for customers in the past, and we found it a way. It doesn't answer all the questions, but it helps us to really get a handle on the prioritization of where we want to focus our tests, because you can't test everything. And I'll get back to that point later. But this Exposoft performance prioritization matrix has a number of factors in it. And I'll run through these right now. And I'll talk a little bit at the table, but then I'll also give some additional information. First of all, the user and the platform section, what that is this is an effort to break down all the different functions that exist within a piece of software. So the application, the web application, or whatever is going to be under the performance test, you want to look at all the various pertinent functions and list them. So we go in and we try to categorize based on how the software is developed, and through interviewing the development teams that have been involved with this, or reviewing help documents or design documents, and we'll go through and we'll categorize. So user and platform section are related because it's categorizing the section of the software, or the function within the software that particular line item is focused on. The next thing that we did, this was actually for customers that have JMeter already implemented. The JMX is the extension for the JMeter script. And we go through and we find out if it's been covered already in their scripts, so we could review their scripts, and that's what we did. The next thing that we did is we go through and determine if the usage, based on our information, is would it be considered high, or low, or medium. And this is an effort to find out that a particular function, how much is it really being exercised within the application? And would it be an area that has a lot of high use? So you want to make sure that if the customers, the users are using that particular function, that it works well. If it's one that's hardly ever used, then it would probably be something that would be less prioritized. So I'm going to flip. We've already talked about these. Okay, so again, knowing where you stand. So I'm talking about these fields within the table. Tier 2 customer input is also the customer service complaints, the way this was listed, but basically it's getting information about the customer service complaints. If there's a particular area that is not performing well within the software, it is worthwhile to get the views from the customer service that's collecting those complaints, because not always, but at certain, depending on what that complaint is, it could well be involved with performance issues, or be areas that you want to go and test, evaluate, and make sure are properly functioning from a performance perspective. The other benefit to this is listed here in the bullets, is it's real customers. These are people that are really feeling it, the end user, which is really the critical voice that any service provider would want to make sure that they're taken care of. So the other thing is this determinant relevance, and what that means is it's for any of the customer complaints, obviously you'd want to see if it's related to the software that you under evaluation, and is it a performance issue? Not all customer complaints are going to be related to performance. So it's just another point to make sure that you don't miss it, because it certainly could be related to performance, and you don't want to just ignore it. Another factor is Google Analytics, and we think that this is very important because we found that certain customers that while if they haven't had experience with this, or they're new into the performance evaluation game, they will not know exactly how their website is being performing. And one of the ways to do this is to use Google Analytics, where you can go to each web page and you put a small script embedded within the HTML, and you're going to get statistics. Two of those reports we find very useful. This first one is the Google Analytics page. It's called a page views report, and very straightforward. How many times was the page used? The average time on the page. So it's a simple representation. And but it does give insight to how the particular web page within the application is being utilized and how often. But the other one, which is the behavior flow report, now up on the screen, this provides information for how people enter the page or enter the website, the web application, and how they move through the web application. So there's 16,000 that were here and then progressed over to here, where this particular function was used 20 times. It was fed from down here, it was fed from up here. This particular function here, you could say this one, is only 4.7 or 2.78 K, which is 2,700 times.
Hey, Ed, we have a question that came in from the audience about the Google Analytics stuff. I was just wondering, this is really good stuff. I can see that this could be actually seen as the missing link, that a lot of people that are doing performance testing are actually just kind of guessing at what users really do or what they think they do, based on what maybe the marketing folks tell them or whatever. But the question is, is how do you implement the Google Analytics, and is it difficult to get going? And the other thing, so that's the first question, and the other question that came in about this is that do you have to pay for Google Analytics, or can performance testers just put this code in or do whatever and use it on their own, or is this something you have to pay for? So those two questions.
Okay, well, those are good questions, and certainly ones I had early on. One of the nice things about Google Analytics is that it's free. So I'll talk to that first. The Google Analytics is free of charge. These reports you can get, and if you're using Chrome, which is normally how I've been implementing it and accessing the information, there's some nice plugins. So the way that it's implemented is that there's a small bit of code that would be embedded within the HTML of any given web page. The downside, it's really not a downside, it actually winds up, it's not that difficult, is that you edit every web page that you want to have statistics on, you can put the code in, and then it will start to register. And the way that you can get the results, the easiest way that we found, once the website starts generating the statistics, is to just go to get the plugin, the Google Analytics plugin for Chrome. I think it's available for the other browsers. Maybe not because it's Google, but the plugin for Chrome is really nice, because once you go to if you go to a web page that it's activated on, it'll immediately show the numbers for different parts of the website. Actually, the web page, the different parts of the web page, and how they're being activated. So it's free. There's a small bit of code. We can make that available, and it's certainly, if you searched on Google Analytics and on Google, I'm sure that you could find that snippet of code that would go into the HTML. So I think that answered that. Is there anything else there, Phil, for that one?
I think that's it. I think that answers the question. Thanks a lot, Ed. I'll let you keep going.
Yeah, sure. Okay. Yeah, anyway, but yeah, suffice it to say, it's very insightful. And it allows you to focus on where you need to focus. Okay, that's that's previous. I don't need that. We've talked about that. The Google Analytics behavior flow, yeah, it can help you optimize the application, the actual software for the application. But from a performance perspective, it can help you also by showing the flow. You can develop your performance tests to actually follow the flows. Again, in an effort to simulate a more real-world environment with regard to the testing that you're doing. And finally, you can use it, I'll just throw this out, as a predictor of a future traffic load. In other words, if you know that these particular handful of functions is being carried on within the application, and then you know that perhaps one is going to be terminated. Maybe there's some sort of help function you're no longer going to facilitate, and it might be facilitated by other links within your website. Then you can make predictions of how you think the traffic will flow, and then develop your performance scripts in JMeter to accommodate that change and see how the application will behave. So some other things to keep in mind with regard to knowing where you stand. With regard to that table that we had, the functional isolation, what that means is that to the extent where it's possible, to find out how given functions relate to other functions, with regard to the engineering aspects, the architecture of the software.
Hey,
so
Ed,
that,
Ed, we got one more.
Yeah.
One more question on Google Analytics. One of the testers was asking, is there any resources on how to help learn how to use Google Analytics? Which I know we had some discussions on that before. It's not. Can you share some resources possibly, or on how to learn that stuff?
Well, yeah, I can't do it right now, Phil, but I certainly can provide the links later.
Okay, great.
There's a lot on, and we found that some are very helpful.
Yeah.
So that's not a problem.
Okay. Yeah. Another question on reading all the stats. I think maybe that might be a good subject for a blog as well, or a white paper. So we'll let you cover that later.
Okay. Not a problem. Yeah, it can be very involved, and that's actually part of the challenge with all of this is keeping your eye on the main items. There's some, the 80-20, right? 80-20 rule of what is important. You could really get tied down with a whole lot of small details.
Yeah. I've looked at the analytics, and it's not at all that clear to me, but maybe it is to you.
Well, first and foremost, it's just the volume for looking for where there's heavy activity on the site.
Right.
Something that many just don't have real numbers for.
Right.
So I think it's important to know it. So anyway, yeah, we'll be able to provide some additional information.
Good.
Yeah, just going through the last 3 items that were in that chart. We have the functional isolation, which basically means that if there's particular functions, do they overlap? Do certain functions share a database? Did certain functions, share some sort of external system outside of the software, but within the system, some external system component where they could potentially have collisions or interact in negative ways, which performance testing by simultaneously would help bear out. Are there negative tests that are required? The level and the type. So this is really sitting down and looking at any particular function within the software. Is there a negative test that's required to help exercise that? Or is it one that's just not used that much and there's very little risk? And then the last thing is a general importance factor. And this we also found for a couple of clients was not really taken into account as they were doing their performance testing is, key aspects. Does this particular function within the software involve something very important like money, handling of processing of fees, or in the case of, let's say, if it was an educational piece of software, school grades. Uh, you cannot lose the school grades, or it's going to be a very big problem. So there's some very key things and key elements that would exist within a piece of software, and crown jewels, if you will, that you have to make sure that it's also part of the focus. So if in fact they should be, then that should be identified within that prioritization list as well. Okay, so you know where you stand, you did your tests and so forth, but what do you need? Well, what type of business do you have? We talked about these monetary transactions and so forth, but there's some very simple metrics. Customer expectations. Customer expectations are increasing. And they talked about bounce rates. You could look at these numbers. I won't read through all of them, but if a page takes more than 2 seconds to load during this particular SOSA test, they said there's 20, this particular survey, they found that 2 seconds, more than 2 seconds, 26% of the people wouldn't come back. And at 41% if it's 10 seconds. So there's more and more pressure to deliver a good experience, and the customer expectations are certainly increasing. So one thing I wanted to point out is this test application server. If you're going to be doing load testing, you need a test application server. Or you should, to the extent that you can have one and get one, because it has a number of benefits. One, it limits the exposure to real customers that would be using a production system. You can schedule tests at any time. And some of these tests can go on for hours and hours. And so if you were saying, oh, I have to do my performance test in the middle of the night, or something went wrong, you want to rerun them, or make some changes, you can't do that. Or you certainly don't have the flexibility you would with a test application server. But some of the challenges are it has to be properly sized if you're going to put it together to actually mimic your production environment. And it needs to be maintained. Backups, database reconfigurations. Every time that you run it, you have to, maybe you have to reset the databases to go rerun tests again. This isn't just for performance tests, this is testing in general, automated testing in general. So these kind of functions need to be supported. So without a test application server, it could be very difficult. So knowing what you need, JMeter master slave configurations I wanted to talk about a little bit. Just something to keep in mind with regard to how to set up the master slave. First of all, master slave is very important because you don't want to, if you want to generate a lot of virtual users, they call them V users, you need to have a number of slaves. So let's say in this particular diagram, each of these are the slaves, the master's down here, and you're driving traffic against this particular server. This is the test server, the application server. And so each one of these could be generating, maybe 500 users, or maybe 1,000. It really depends on the type of test that's being executed to the number of users and all the details that go into that. But suffice it to say that you want to be able to scale and drive the server. And it just can't be done with one client to generate any significant load. I think anybody involved with testing will know that you need the master-slave configuration. The good news is JMeter is pretty easy to set up the master-slave. We have directions for that as well for people that would like to know the details of that. We can share.
Ed had another question come in that's kind of related to slaves and being able to generate the load. The question is, they're talking about defining the number of concurrent users. A lot of clients, I think we've had this discussion before, they have 1,000 people registered, and they want to slam 1,000 against their servers doing whatever. And so the question is, how do you really calculate how many people are doing what? And would that go back to the Google Analytics, or that the Google Analytics shows the path, but it doesn't really show how many people you should be trying to simulate doing stuff?
Well, that's not entirely true, because the Google Analytics can show over time the amount of users that are getting onto the site or getting on a particular function within the site. So there is detail to that for how aggressively people are coming at it. And that's actually one of the benefits of Google Analytics, is you can start to get that kind of view. I don't want to get into this right now, but there are ways that you can actually write your code to do anything. Software can be written to do just about anything. And if there are nuances within some of the testing that you really wanted that wasn't provided by Google Analytics, you certainly could write it into your own code to take peg counts and so forth that people are getting on a certain functions within the application.
Right. Okay. Well, that may be
but that's and if you have, just to finish my thought, Phil, that if you have 1,000 users registered, yeah, that doesn't mean they're all using it at the same time. So that's not a realistic test.
right.
So
How do you determine what a realistic test would be?
well, yeah, that's part of what this is, and part of the Google Analytics, as you say, is a good indicator for how many people are getting onto the application and utilizing it.
Mm-hmm.
It doesn't answer all the questions, but it certainly can give a feel for that, to see how active that particular site is. For instance, you could have 1,000 people registered, but maybe maybe only 20 are using it across an hour, and maybe only 3 at one time.
Right.
So Google Analytics would help bear that out. So yeah, and let me continue with this, and maybe I'll answer some of the.
Okay.
Give some additional clarity. Okay, so this master slave configuration here, this is pretty straightforward. You have the master, as I was saying, and you have the slaves, and it generates the server. But getting to your point of trying to model a real-world scenario, one of the things, well, just some of the benefits here. This slide, my apologies, is not laid out perfectly, but the benefits, it helps offload the master, which is essential. And you can emulate users from different areas and different locations. Let me show you what I mean by that. So in this particular case, I'll call this regional. And you have the JMeter slaves. If you went on to like AWS, or if you went on to Azure, which we also had success with. We've had success with both as far as setting up virtual machines in the cloud at different locations to be able to drive load. So if there were 2 application servers, let's say us as a service provider are going to test different applications around the United States, we might want to just have established somewhere in the center of the United States these JMeter slave configurations that would be able to drive traffic over to either application 1 over here for one client, application 2 for another client, or maybe it's the same client if they have different applications spread around different areas. And the advantage of this is that if I'm sitting in China, I don't want to be running my tests and slaves from China. I would want them in a place where there's very low, limited latency. And by putting them, in the middle of the United States in a well-performing network like Azure or AWS, it would serve that purpose. So it's a simple method for driving load and allows test support for a centralized location. Basically what I just said. Now, a multi-regional, in this particular case, you could have, let's say the application server under test is in the middle of the United States. Now, in an effort to go and develop realistic load, you would want to simulate your real users. And one of the ways to do this is to actually take advantage of the Azure cloud or AWS and set up your slaves in different regions, much like your customers would be. And in this way, it helps develop a load that is more realistic. It has the latencies that might be built in with the customers coming in from different locations. And you'd be able to drive the application server. And in fact, you'd be able to extend this to international areas. This is an example, Venezuela or over into, what is that? It's France, yeah. And you could have the slaves put, around the world. There are ways to configure this. There's, I believe, some proxy work that would need to be done to be able to configure JMeter like this, but it is certainly possible. Okay. Skipping the yellow and getting to this one. This one, I think, also in the spirit of trying to emulate real world, something else you want to keep in mind. If you're looking at the loads that are being generated and trying to figure out what the application under test is really experiencing, you can go and configure JMeter in this multi-regional scenario like we talked about with the slaves. But other things to keep in mind is the type of calls that you're putting in. For instance, we had one customer that was asking us to test their website utilizing APIs, and that's fine. And we could drive it fast. But what we found was that utilizing HTML, and if you know anything about the protocols, it's probably not a big surprise, that it was considerably slower, and that the application could only handle a limited number of requests relative to the API. And you can see here what this was is 100 users. So this one was up over 1,500 for the web, but the API was able to drive much faster, and they could handle many more users and respond in kind. So the point is that you want to make sure that you can understand when you're developing these tests that you want to develop real. We talk about production environment. If people aren't attacking the web application utilizing APIs, then while that might be a test to exercise some of the software functionality, it's really not encompassing what would really be experienced by the application under production load. So knowing what you need, system profile for JMeter. This slide I put in here because one thing that needs to be kept in mind is that when you configure your JMeter master and slaves and take into account the application server, you have to make sure that the devices are not going to be overdriven. And this means that the slave configurations need to have appropriate memory, disk drive capacity for collection of data is necessary, and CPU utilization. So when we run tests, we're always monitoring those items to make sure that the slaves are executing with regard to driving load, and that they're not encumbering the tests because they don't have enough capacity. And the same goes for the master. So the application server, performance and load computers, and in fact all the associated networks to the extent that they have enough capacity to drive the application. They have to make sure that they're scaled properly and monitored as the tests are being performed. Because what you don't want is you don't want test results coming in to say, oh, look, the application is not responding, and it's because the slaves didn't have the capacity to go and even initiate the tests. So you have to make sure that the slaves have enough capacity and that you have enough slaves. So getting real.
Ed, one more.
You need to create
one question when you're.
Sorry?
Ed, a question when you're talking about the capacity of the slaves. I mean, if you're using AWS or Azure or whatever, do we have control of that, or can we specify that?
Yeah, you can size the different machines within the cloud as far as CPU sizing and memory sizing, and then like if it's a Windows 10 configuration that you're using, you can set up utilities to monitor the the CPU and the memory and links. So yeah, it is scalable and it is sizable, depending on what you need. That's one of the nice things about the virtual environments.
Cool. I'll let you keep.
So yeah, okay. Getting real then, creating realistic tests. We talk about mirroring the production environment to the extent possible, focusing on critical areas, utilizing the performance prioritization matrix or some other similar function to make sure that you're keeping your eye on some key elements that should be prioritized. And this is a spelling error, my apologies for that, but beware of 2 test scripts. Well, it's a little screwed up, but it brings focus to the point. Too many test scripts. So 1, avoiding non-critical areas. These IDEs now for creating scripts, for doing a performance testing or any other testing, it is very easy to create a lot of tests. Record tests, and then you run the tests, and every day you could be running the tests or whatever time frame that you feel appropriate, and there's too many of them, or you wind up just over time, yeah, they're running and it's not a problem, and you start to get all these piling up, and it gets in the way of actually being focused on what should be the priority. So this idea of prioritization matrices and so forth is something that should be revisited periodically to make sure that the focus is where it should be. And yeah, it can create a real test management challenge if you're not doing that as a periodic form of maintenance. So one last thing I wanted to say here was that this standalone performance tests have merit. Now, I talked about my simplistic diagrams before, the simplistic metaphor. If you look on this side, H1, so that's just a happy path, or simple functional test. This is expanding it out to the negative boundary cases, and across time and performance, and then actually looking at running multiple tests simultaneously in this last part. But there is value even here if you're only going to run one isolated test. And we found that some clients have missed that. We try to talk about duplicating a production environment as much as you can, getting realistic, really what's happening within the environment, or what's really occurring to the application, what can be expected to occur, and that is a noble thing to aspire to, but you can't do everything, so you do need to set priorities. But we find that value starts even with a single test, where you can drive that particular function and figure out if it's performing well. Is that as good as running other tests simultaneously that might interact with that test? Well, maybe it's not from a performance perspective, but it still has merit relative to just this simple case that's shown all the way on the left. So I think this is a game of statistics, and you really have to work hard to set the prioritization and upkeep the prioritization. So that's really all the formal documentation I wanted to present today. I very much appreciate everybody listening. And we have some additional documents that are available at that link that you can search and find under JMeter. This particular presentation is not there yet, but it will be in the next few days. And you can find that there, or just email us and we can make sure you can, if you want a copy of it, there's actually a formal white paper that goes into a bit more detail for all the things I talked about today.
Right. Well, thanks a lot, Ed. We really appreciate you sharing your knowledge on load testing in general, as well as some specific JMeter stuff. And the Google Analytics was really very interesting. There were a ton of questions that came in that I didn't want to interrupt you because I know we have a limited time here. So I'm hoping that you have time to get to those questions on the blog. And just as some notes for our viewers, for our audience, we have this software testing white paper library here, which does have quite a few great resources on not only performance testing, but also automated testing, agile, and so on. So we will be posting the recording on YouTube, so you could follow us on the YouTube channel as well as any of the other social media channels where you can find out about the recording and as well as the slides and other upcoming webinars and events that we're at. So thanks a lot, everyone, and thanks again to Ed for sharing your knowledge on JMeter. I know you've been really digging into this for the last 6 to 9 months, and appreciate you sharing your hands-on knowledge. So thanks, everyone, and that concludes the webinar. Thanks a lot, Ed.
Okay, thank you. Thanks, everybody.